electromagnetic wave. Under this, the propagation vector, and polarization, and then we have the velocity, phase velocity, and group velocity concept. Again, for a given E, how to find how to get the magnetic field R H. And then the boundary condition, pointing vector, yes. Any idea who is related? Yes, pointing vector. E cross H. So E cross H. And then and then the normal incidence. See, normal oblique, and then brusque. So these are all the topics that I try to cover in this class. And what you see in the worksheet is also consists problems from this topic. Okay. So let's say let's begin with how to represent a wave is a time varying field mathematically. Suppose if you want to know the electric field associated, the electric field of Z comma T, E naught, some amplitude, E naught, e to the power I K Z minus 1. Is that correct? Or there is no I here? I is there? Is it I is common here? Common. Okay. So what if I write E0 e to the power of I Kz plus omega? Can I write an expression? Yes. So what is the difference between these? The direction. So what do you call this one? Within bracket, whatever is there. Phase or argument. You can say argument. So how we can express this e to the power of I times of this? It's a combination of cos and sine. Okay. So that means it's a sinusoidal wave. And it is the moment you say sinusoidal, it's a harmonic impact. So they move periodically, they come up. Okay. Now, if I say mostly the argument is a dimensionless constant, where your k is what? 2 pi by lambda. And sometimes they also write beta. Engineering book, if you look at any engineering book, if you take, you will have a beta. So it's a wave vector basically. And omega, 2 pi nu, angular frequency. So 2 pi nu. So 2 pi nu is the angular frequency. The coefficient of time is dimensionally, it should be a frequency of 1 over time. And z is the direction. And your k should be 1 over of meter. So there is the spatial coordinates. So therefore this becomes dimensionless quantity. And the fundamental difference between these are these. So let's say if I consider the first one. Now your kz minus omega t is a constant, let's say. And I'm very lazy, I will take this as a constant 0. And it's also a constant. Okay. So let's take some constant value and I assume that as a z. Now your kz will become omega t, and then if I do this dz by dt, what I will get is omega by k. The omega by k is the phase velocity, or in general, let's see if it is in a free space or phase velocity, as it was pointing out clearly. In a medium, it becomes a phase velocity. Okay. So that means the velocity of the wave is coming out of this. So that means it's moving. dz by dt is nothing but the variation in z direction. How this moves and what speed it moves in the z direction. So the moment you see that kz minus omega t, the direction of wave propagation is along z. And this is a, let's say, your variation can be along I or j cap or combination of I cap plus j cap. So you have no problem with this. The direction in which it can move, in all three possibilities are okay. So the variation can be in the x, okay, amplitude variation. It can be like this. The variation amplitude that we have shown just now in the demonstration, isn't it? The red one. The red vertical is nothing but the variation in the x-axis. But how this thing moves? It's in the z direction. The magnetic field, if you want to know, it moves in this vibration along y, but this moves in this direction. So therefore, you have either it can be I or j. What about this I plus j? That means it's in a plane. So the vibration can be in the plane, but still it can penetrate along the z direction. So all three possibilities are possible. Or you can say minus, yes, minus also possible. I plus j or I minus j. Direction can be anything, but this one gives you the wave is moving in plus z direction. What about this one? Minus z. That means the velocity is negative. Velocity cannot be negative. The direction is, the minus sign says that the wave is moving in this direction. If I assume this is 0 and this is a plus z, or this can move in the minus z. So the reflected wave or the wave that goes in the opposite, reverse direction. And that's what this is representation. Okay. Now, if I write, you can also write this. E can be written as T0 e to the power of I omega t minus kz. Let's say x cap. To avoid confusion with this I and this I generally try to use maximum x cap, y cap, okay, x cap class. And mostly I will prefer to use I for the complex quantity. In engineering books there will be g. I or j is 1, square root of minus 1. Okay. Now, if I write in this fashion, it's still legally relevant. I can write in this way. And the propagation direction, second, propagation direction is in which direction this moves? Z direction, positive or negative? Positive. Why? Why you are saying positive? But this is the minus, yes. Minus kz, right? Is it minus z or plus z? Positive, yeah. As long as you get this phase velocity is a positive quantity that will propagate in the plus z direction. So that means this argument, either this can be plus or this can be plus. If it is 1 plus and 1 minus, you can this is the coefficient of z, coefficient of k is the propagation direction. In this example, it's z, not necessarily all the time it can be z. If I can also write this as a E equal to, let's say, E0, e to the power of I, k times x minus omega t. And this vibration will be on, let's say, y. I can still write this. It's a valued electromagnetic wave, electric field representation. Now, if someone asks the direction of the wave, you need to look at the velocity is a positive or negative, and the coefficient of this is what the propagation direction. So the propagation direction k equal to x cap. You are not supposed to say x cap direction. Okay. So therefore, the coefficient of your k determines the propagation direction. First one. And the second one, the difference between this argument, one should be plus, another one is minus. That means it's the positive z or positive the coefficient of k, whichever is there. Okay. If the coefficient of k is, let's say, you can also have e equal to e0, e to the power of I, let's say k times x cap plus y cap whole divided by some root 2. These are all to make you confusion. Okay. Minus omega. Now, what will be the propagation direction? Second. Or let's put this is, let's say, 3x 4y. I can also choose this. 3x plus 4y divided by root 2. The propagation vector from this, if it is asked, it's in a positive for sure. Velocity of the wave is positive. The waveplane is going to move on the positive axis. Which direction? X cap plus y cap divided by root 2. So 3x cap plus 4y cap divided by root 2 is the propagation direction. Okay. So if I say this will come only in the case of oblique incident where it will be in a plane. You will have a plane in which wave will be vibrating and then hitting the boundary. Okay. So this is how you can increase the confusion or the complexity in the understanding with the only propagation direction. So you can look at this problem number, let's say 7. Let's start with 7 in your example. So the problem will be in this section will be 7, 35, 42, 244, and then let's say number 4, number 45. So this will be the direction in which we are going to go in this section. Is that clear so far? I just want to audibility and the writing. If it is any problem, you can let me know so that I can correct. Okay. So far it's good. So what is the learning takeaway now? What the propagation direction? We are very clear. The coefficient of k gives the propagation direction. The argument 1 plus and minus 1. That means the spatial part and time part. So when you say wave, it should have a spatial as well as time part. So this argument and only sine and cos are the only periodic functions. In the world, there is no other periodic that you are going to see. In your entire MSc program or even in anywhere wherever you go, if it's asked periodic function, either sine or cos. No other function is a periodic in both time. So all the electromagnetic waves are time varying. Is that clear? Okay. Now, if I simply ask a question, what is wave? What is this wave? If you say, then you will say something as a wave. That I am a wave. This chalk is a wave. Yes, eligible to become a wave. Under what context? What is the definition for a wave? Wavelength. If there exists a wavelength, you will say it is a wave. And why you need a wavelength? You can say wavelength. Any thought? Yes, please.
So, photons interact with matter until it's behave like a wave.
Photons interact with the matter.
Until it's behave like a wave.
Behave. No, my question is, what is wave?
Vibrations.
Vibrations. Very good. Vibration travels in the medium. Okay. Vibration that travels in the medium. Be confident. Yes. Right. Any question on that? Matter waves of this. Where you have seen the wave? The seashore? Yes, that's we call this a wave. Yeah. So, okay. Basically, any disturbance. Disturbance maintain its structure in speed and occupies space and time. So that when I am speaking, all this vibration, partially cut, the vibration is been traveling and it reaches you and it cannot reach us beyond this class. Right? Because it reflects back and something happens. Now it dies. Even you cannot, I cannot listen my own words after a certain fraction of a second. Yeah? So by the time it dies, so the disturbance is being maintained. So that means if I say like this, and it goes at time t equal to 0, and position x comma y comma z equal to 0. Okay, and then it maintains this structure like this, t not equal to 0, and at some points y comma z at later point of time. Then this is eligible as a wave. Okay. So any disturbance that maintains its structure without it losing its structure. Structure, if it loses, that means that something is dying. Now, if I say Ayyappan, and then if you are able to listen till the word last letter N, then it is not dying. If I pronounce Ayyappan and you listen as A, that means gone. Okay, that's what happens in the case of the light that penetrates in the foggy environment. It dies this way. That's why the serial pollution of vehicles happens in the car. Yeah. Okay, so that's why we are always representing whenever you say wave, it's not only the spatial dimensions, spatial part. It also involves time. Time is one of the coordinate here. So you always see the time part comes without the default. And the problems, before going into the problem, in this electromagnetic theory, always emphasize if I the electrostatic and magnetostatic, you might have done problems. Compared to other subjects, in this subject you have to there is one more checkpoint, the extra effort you need to do. Okay, the first thing is if given information, there will be a formula. You apply the formula, you get a result, and look into one of the answers. Okay, as Joseph was saying, apart from one answer, others are destructive. I saw the video. So the destructive is okay. And in this particularly the electromagnetic theory, you will have a given information, you know the formula, you cannot directly substitute. There is one more checkpoint called you need to choose the coordinate system. The problem is asked which coordinate system. If it is asked del cross E, and if the given information is r theta phi, your del operator cannot be in the Cartesian. If you try to do the problem, you will never end. You will only spend time on time, and then you lose time. Okay? So therefore, this dimension of the coordinate system. The coordinate system is what important to choose. Okay, and then corresponding operator in that particular coordinate system you need to choose. So your problem is much easier. So this one additional step is there with respect to electromagnetic. So that you have to be more careful. Now let's go into the problem number 7. So when you say the wave, basically the Maxwell's equation so when you say the Maxwell's, if this is del dot E rho by epsilon, and then del dot B equal to 0, del cross E rho B by rho T, del cross B what? Zero. J plus epsilon naught do E by do T. Your D equal to mu 0 H. If you want to write in terms of H equal to, so your B and H are related as B equal to mu into H. Okay. Is that correct? Plus M for what? Right? Yeah. Oh, that we are not going into the mechanism aspect. We are only stopping with ourselves in that respective regions. Yeah. Okay. So basically, we use this mu, and then let's say mu here epsilon. In general, let's put it in this fashion: mu epsilon. Okay. Where J is what? Current density. Yeah. So del cross B equal to this. Okay. So from here we will get the wave equation. I hope you all know how to get the wave equation. But the problem number 7, what is asked is you need to choose this. So your del will become I times k vector, and partial with respect to time will become I omega minus. Okay. So dou by dou t become minus I omega, and your del operator will become I times k. Okay. So this is what the conversion. If you want to know how it is coming, you can explain. Because it's d by dt, your d is a time varying function. Now in this equation, let's say this one, you can write this as E equal to ES e to the power of minus j omega t, j I omega. Isn't it? Because your ES can be written as only the spatial part. Where your ES is a phasor, where ES can be written as E0 amplitude, that depends on the spatial part, e to the power of I or minus I k times z. Okay. So this is only depending on spatial part, and this is the time part. Now if I differentiate this vector dou E by dou t, for example, I will get ES is independent of time. So only differentiation is e to the power of minus I omega t, it will be e to the power of I omega t. The coefficient of t is minus I omega. So minus I omega times E will be. Isn't it? So if I differentiate this, let's say dou E by dou t will be your ES e to the power of minus I omega t multiplied I omega with the minus sign. So therefore minus I omega into E vector, because the remaining is nothing but E vector. So the operator dou by dou t is corresponds to minus I omega. Now you can ask the question, if I interchange this kz minus omega t, that time it should be plus I omega. But the corresponding del operator will become minus omega. So therefore, this del operator, how it is coming, if you want to know, then again integrate this del cross E. In the same fashion, del cross, you have E0 e to the power of I kz minus omega. If I use the same function, now what I will get? Your k dot z, then your del operator is basically spatial operator. When you do the spatial operator, time is going to be a constant. Only you are going to differentiate this. Now what the coefficient of z will become I times k. So ik will be coming for this. So now this entire equation I can rewrite in terms of operator k. Okay, I think that is the problem that is given. Consider the propagation of electromagnetic wave in a linear, homogeneous, and isotropic medium with electric permittivity epsilon and magnetic permeability B. For a plane wave of angular frequency omega and propagation vector k propagating in the medium, Maxwell equation reduced. So that means if I say a homogeneous linear and what is the another thing is isotropic. Whenever you see such thing, basically what they are saying is your rho charge density is zero. The current J is also zero. That is the point. Whenever you say isotropic, linear, homogeneous, the medium is not having any kind of excess charge, the charge-free region. Now, when you say charge-free region, this Maxwell equation will be reduced. How it is going to reduce? Let's say your del will become I times k vector dot e vector will be equal to 0. Or you can say that k vector dot e vector is equal to. That means this implies that the electric field is perpendicular to k. Is that correct? Whenever you say dot product is 0, they are mutually perpendicular. The physical meaning of dot product. A dot B, if I say projection of one vector along with another vector. It's like a two jaws of a crocodile. It just catches. So projection of one with other. If it is 0, it's a mutually perpendicular. Is that it? Now the second relation, same goes k vector dot b vector equal to 0. Is that it? And the third one, curl of E. That means I times k vector cross E vector will be equal to minus of minus I omega times B. So basically minus of minus plus. So we have k vector cross E vector will be equal to omega times minus dou v by dou t. Okay. And if you want to write that in terms of B equal to mu h, you have k vector cross E vector will be equal to omega times mu times h. Because B equal to mu times h. And similarly the last one.
Sir,
Yes, please.
so how you wrote that as like k vector and I vector?
Okay. So that's what I tried to explain here. Let's say del cross E, you take this cross product. And del operator is a basically spatial relation. And if you consider your only propagation in z direction, now you del operator will become d by dz. Okay, in the Cartesian. Now if you differentiate this, what you will get? Ik will be getting as a coefficient, and the remaining wave will be the both left and right will have the wave. Then the dimensionally what I am saying is your del operator is replaced as I times t. Okay. So same way for d by dt. If you d by dt, just now erase. If you differentiate as a function of time, you get minus I omega. This choice is I consider E equal to E0 e to the power of ikz minus omega. If I choose E0 e to the power of I omega t minus kz, then what will happen? This will stop. The negative sign will stop. So this gets negative and this gets positive. So still you will get the same relation. Okay. There is Maxwell equation is not going to change. Okay. Is that clear?
Yes.
Now the last one, if you do, let's say your del cross B vector will be equal to mu times j. Because j is 0, so this can be considered 0 plus. And then we have mu epsilon dou E by dou T. And this, let's say, k vector cross B vector times your I will be equal to, this will become mu epsilon, this will become I to minus sin I omega times E. So this will become, I gets cancelled out, your k cross B will be equal to mu epsilon omega with a minus sign and then E. Okay. So whichever option is this, then that will be the answer. You will have four answers: k dot E, k dot H0, k cross E, then k cross H. It is given in terms of H, so you can bring this mu here. So your k cross H will become minus epsilon omega times E. See, this is another problem. You will get the answer, but you have to look at the options only that time. Based on the requirement, you have to modify your question or your answer. Now I can stop here if answer is not in the case of k cross B. In answer it is k cross H, you have to modify the value. Okay. So only the time you have to look at it. Until this is what the major instruction that we receive from our panel. You never ever look at the options. Look at the problem, try to solve. Once you have done, then go to the answer for option and then choose one. If not, go to the next one. Okay. Whether you can able to modify some tinkering, this is called tinkering. You do it as some kind of modification such that you get the result. Not drastically changing. I do not do. I apply a logic here, D and H relation. That's all you need to do. Otherwise, you will get lost. Or you will get the only confusion or destruction happens. And by mistake, you choose the negative one. Is that clear so far? How it is done? Yes? Okay. Now let's move on to, so this we have done. Now let's move on to the 30. The problems are not linear. Okay. So we'll pick some here there, but still we'll solve most of them. Yeah. In fact, all of them I'm ready to solve. Now the 35 is the question very good. Now the question very good. Number one. So the question number now 35. So the previous one was 7, and what is the answer by the way for the 7? Option? It's available. Now the 35th question, the electric field of a plane electromagnetic wave is represented as E equal to E0 exponential I times k cos alpha plus, this is along x cap, I times x cap, and then you have y cap k sin alpha, and then you have minus omega. If x cap, y cap are the Cartesian unit vectors, the wave vector of the electromagnetic waves. So what will be the wave vector k? I believe this is maybe the typo error, maybe x and y instead of x cap. Nothing wrong, but still, if you say x, some number, if you put the x cap, it's 1. That's the difference. Even you can solve this x cap, the coefficient is 1, basically. Yeah? So 1 times cos alpha is the coefficient of it. Now, what is the wave vector k? And which direction this wave is moving? Say again? Plus x. X plus y. Yeah. So x plus y direction. This is the plane. The wave that moves in a plane. The vibrations in the plane. Okay. So that's something like you have let's say this is a kind of interface. And then this wave is coming like this. Okay? It's in the plane. And this plane, the electric field is vibrating. So you have an x and then y. Let's say this. Okay? So the wave vector k is the velocity will be positive because one is plus another is minus. The coefficient of k, I can write this as a common k can be pulled out. Then what will happen is you have x cap cos alpha plus y cap sin alpha. So that will be the propagation direction. Okay. So it's as simple as this. And I hope you learn the answer also. And the answer given in terms of the modulus k, let's say. Your k vector is your k cap, like any vector is x cap and then let's say a cap and a modulus k. So modulus k value. So this is the option. And then the 42. 42 is about the polarization. So the state of polarization of light with the electric field vector, your E, is represented as, let's say, I cap E0 cos kz minus omega t, and then you have minus j cap E0 cos kz minus omega t. So the state of polarization of light with the electric field E equal to I cap E0 cos kz minus omega t minus I times E0 again cos kz minus omega t. Okay. So for polarization, what we have seen is you should have. So what will be the polarization in this? In the possible answer. It's a linear. So the options are linearly polarized, elliptical, circular. These are the only three options we give. Okay. Now for polarization, you have E, which is two components, Ex and Ey. And amplitude of E is, you need to look into amplitude. You have Ex square plus Ey square whole power 1 by 2. And the theta is tan inverse of Ey divided by Ex, components ratio. So this is what the theta is. Okay. Now if you take this, you have what? Y component is J. That is this component minus E0 cos kz minus alpha. And then you look at these amplitudes are the same. The amplitudes are the same, that means these two are same. Either it can be a linear, elliptical, or a circular. Anything can happen with respect to this, you cannot determine. But now you come up with the tan inverse of, let's say, minus E0 cos kz minus omega t divided by again E0 cos kz minus omega. So basically there is no change in the phase, both of them in the same phase. Yeah. So what will happen? Tan inverse of minus 1. And for what value you will get this? For 1. Second. Or let's say tan inverse is. So let's say if I put this minus sign in this one, your Ex equal to minus Ey other way around. And then if I put this tan inverse of 1, it's going to be 45 degree. So the angle is 45 degree. And then, so because your x equal to minus, so that means the phase difference will be 180. Yeah? You can say in the pairs. And still, if it is angle is, let's say this is 45 degree, and then amplitudes are the same, then it can be only a linear motion. Okay? Linear at an angle 45 degree in the xy plane, because So let's say you can write this E can be written as E0 cos k z minus omega t with respect to I cap minus j cap. So this will tell me, if I pull out this I cap minus j, this is a constant. I can write it this way. And this I cap minus j is what representing as a plane. You have an xy plane. So let's say this is I cap and this is your y cap, j cap. Then x minus, so x is a positive and this will be minus. So this is in this direction. So, and the angle is going to be 45 degree with respect to x axis. And this moves in this vibration. The vibration in this plane, x minus y. So that means it's a linear and then makes an angle 45 degree with respect to x axis. Yeah. So linearly polarized at 45 degree to x axis. Is it all of tan plus, okay, if I put minus, what will happen? You will get a minus 45 degree. Yeah, then minus 40. Okay. So basically, your amplitude ratio is what the angle is. Yes, correct. If theta is E y component divided by Ex component. And the mathematics behind this, how we are writing this, we can prove. There is a proof for this. Polarization proof if you want. If you need anyone, you can ask. I will share the notes if you want. Okay. And about the polarization, linear, circular, whatever I showed here, the mathematics is available. We can share. Okay. So if I do that, you will lose time. So Prakash has said, only problems. So I speak with that. Is there any questions so far? Is that clear to everybody? Yeah. Now you can think of if it is a sign, what will happen? Let's try to generate a new problem. If it is a sign and there is a plus or minus, doesn't matter, depending on the variable. If it is a sign, now what will happen? So only if I do this, E equal to E0 along my cap cos kz minus omega t, and then minus j cap E0 sin kz minus omega. Then, second, circular. Why circular? 90 degree difference. Where you are getting 90 degrees difference. Sine, cos and sine are 90 degree difference. So this can be written the same way as a cos, but theta plus pi by 2. Okay. So sine pi by 2 plus theta is cos theta. So you will get a minus. This minus sign is there. That negative sign also you need to put. Then the angle will be minus pi by 2. Minus pi by 2 means is a left circular or right circular. So let's say we have theta will be equal to tan inverse of, let's say your y component is minus sine kz minus omega t whole divided by cos kz minus omega. Is that right? Amplitude are the same. Your Ex equal to Ey and theta will be equal to, let's say this becomes tan inverse of term of, let's say, minus of kz minus omega. Now if you substitute, what you get is only theta will become, let's say, minus kz minus omega t. Is that it? So now your theta value is this. Now at z equal to 0, put the origin z equal to 0. Then this will become theta will become, theta is proportional to t, directly proportional. So when time is increasing, your theta is going to increase. So theta is going to increase means, so let's say, so you have a vector here, and this vector moves in this fashion. This is what the theta is. As the time increases, the theta increases. That means it's a counterclockwise or left circular polarization. So LCP, left circular polarization. So one small change. So from cos to sine. So you end up with this. Okay. If this is a plus sign, Again, one more problem. If this is a plus sign, you will have a positive sign here, right? Then it becomes right circular polarization. Okay? So that's how you need to discuss with your friends. If I change these patterns, logically you have to discuss. Then you will get a new problems. Right? Now you can set your own problem. Now you know how to ask question. Okay? That is very important. Any questions so far? So for that problem, this angle will be, let's say, minus 45 degree with respect to x-axis. So from the given option, you can see that linearly polarized along z. Along z-axis also you can linearly polarize. Yeah. Okay. Now let's move on to 43. So for third problem, the polarization of a wave with electric field. I hope you can give the answer right now. Take your time and then. The electric field E is given as E0 e to the power of j omega t plus beta times z. So basically it's a k. I can put this k itself. Either beta equal to 3. About, let's say, x cap plus y cap. This linear elliptical left-handed circular, right-handed circular. Yes. So what are the amplitudes? Component wise, like this if you want to write. How you get this? So you have E0, let's say cos omega t plus kz plus the j or I let me put this I sin kz or omega t plus kz. Okay, and then whole times x cap plus. So that means these values, amplitude there is no change, amplitude is same. And then there is a phase difference is there. If you ask, no phase difference. Phase difference delta is 0. That means a linearly polarized. Then the x component and y component, the coefficient, there is no change in the phase. This is also cos and sin. If I take only real part of this, okay. So if I take real or imaginary, only cos will come or sin will come. But both of them has a I cap plus y cap. So x and y, these both will have the same starting point and same end point. If it is a combination, again it's the same starting and end point. So therefore, this is a linear polarization because where delta is 0, where delta is phase constant. Phase constant is 0, amplitudes are the same, phase constant is 0, it's only linear polarization. Okay? Is that clear? Okay. Now the 44 is a little interesting one. Basically, this and the problem number 35, I believe it's more or less same because you have the 35, yes. In 35 also we can see here k cos alpha plus k sin alpha, isn't it? Okay. So 43 is over. Now it's 44. So the 44th problem is the sum of two oppositely rotating circularly polarized waves of equal amplitude will be. The sum of two oppositely rotating circularly polarized waves. That means let's consider one is left circular polarized like this plus like this. If you overlap these two, what happens? That's the question. The resultant will be what kind of polarized state? Okay. Let's consider your left or right circular will be E0 cos. If I say right circular, what is the concept? Cos phi along I cap plus plus y cap sin phi. Is that it? Just now you have seen for the right circular angle must be pi by 2. Is that it? And if it is a left circular, EL, same amplitude E0, x cap cos phi minus y cap sin phi. Where phi can be, phi is the argument, where phi is kz minus omega. Let's put it in this question. So you're supposed to know how to write the right circular polarization typically and left circular polarization with the same values. Now if I add these two, the resultant, your E resultant ER plus E. So what you will get? E0. So what do you get if you do this sum? Your y component get cancelled out. Now twice E0 x cap cos phi. So that means your amplitude is along only x axis. Okay. So your value is only x axis. So linearly polarized this along x axis. Linearly polarized along x axis. So if you match sandwich two circular polarized, oppositely circularized, one is left and right, one is very linearly polarized. Okay. Whether you are subtracting, if you are subtracting, when you add this you get, when you subtract y direction, linearly again linearly polarized along y direction. This is another question. Okay. So whether it is addition or subtraction gives you a complete picture. The wave is along x-axis or along y-axis. So therefore you need to read this question very carefully and then try to solve. Okay. So we've done up to this 54. Now let's go to the 4. So basically the fourth one, whatever we have seen, it's just generated by me. Wherever there is no gate reference, it's all taken from the textbook or from my class. But this one, wherever is put it as a gate, those are all previous questions. Okay. So the question number 4 is a gate problem, 2008 to mark. A plain electromagnetic wave is given by. Let's start from here. So this will start. So for the question number 4, a plane electromagnetic wave V of z comma t is given as E0 x cap plus e to the power of I delta into I cap into exponential of I times say kz minus omega. At a given location, the number of times E vanishes in 1 second. So the answers are available. In 1 second, how many times the electric field E will get vanished? So that's the question. And then the fixed position. So let's say at fixed position, z, let phi of z comma t equal to kz minus. Just writing this argument itself. And the real part, so here what will happen, the real part, you can write this expansion, let's say x cap of this, and then you e to the power is this. So you have to put in this, let's say, if you expand ez comma t and written as E0 x cap. Let's say this E can be expanded as, and this E also can be expanded, and then you have a cos delta will be there plus I sin delta along I cap. So the x component E0 x cap cos phi of t, and then Ey of z comma t, the y component. So the x component is only the cos of the real part of E z comma t. So then you have E0, then cos along y cap. It's a cos phi of t plus delta. It is because you can expand this as E0 x cap plus, let's say, cos delta plus I times sin delta. Let's say this is along the y cap. Then you have this, if you expand, you have cos, let's put this is a phi of t plus I times sin phi of t. So now if you multiply this, you get x cap times this, y cap times this with this. Isn't it? So if I write only the real part is without imaginary. This can forget. And this also will forget. Now what will happen? You have cos phi of t x cap, the real part is from here you can write. So Ex is this, only cos component. And the y component only cos of your phi of t will be there, and then plus delta. Okay? So that delta is here. Now these two have the components, Ex component and Ey component. Now your electric field must vanish. If you say a vector A is made up of, let's say, Ax I cap plus Ay y cap and Az along k cap, let's say. The moment if I say A is 0, what will happen? The individual components must also become 0. Isn't it? Your Ax, Ay, Az must be 0. When I say E is vanishing, that means your X and Y components must vanish. When it will vanish? Whenever your phi of t will become 90. Yeah. Whenever you have phi of t equal to 90. So in those cases, your E of z and both of them should get vanished. So let's say your cos phi of t must be equal to cos phi of t plus, so let's say delta must be equal to 0. So only these factors must 0. So when these two combinedly become 0, individually, so let's say, because your E0 cannot be 0, it's a trivial solution. That is the amplitude of the wave. This and this combinedly should 0. So when it will happen, that is because you have only when the delta equal to n times y. Or integer. So your cos theta plus n pi must be equal to minus 1 to the power n cos. So let's say your n is an integer. So let's say you have a cos behavior in one cycle. So let's say let's take this. Okay, so it is 0. Then you have pi by 2, and then you have when you reach here 2 pi. It's again maximum. Cos 0 is 1. So you will have in one cycle, you will have twice it become vanishes, the cos function, it vanishes twice. And that means in one cycle, let's say twice it gets vanishes. So therefore, let's say your time period t equal to 2 pi by omega. So omega is the angular frequency. And then in 1 second, let's say 2 into 1 by t will be equal to 2 into omega divided by omega. So twice in every 1 second, so that will become omega. If delta is not equal to an integer times pi, so this vanishes only when n times pi. So the options, if you see here, so an integer omega divided by pi times per second when delta equal to m times pi or n times pi. If I put n times pi. Otherwise, it does not vanish. Okay. So omega by pi times per second if delta equal to n pi. Otherwise, E does not vanish. So that will be the result. Okay. So an integer near omega by pi when delta equal to n pi and 0, not this case. So the answer is omega by pi. Then the first one is this vanishes. The first one is that. Then okay. So I believe with this so we covered mostly on the 25th problem. with 25 is yeah. It's not 45 because only 25. So the 25th will be the electric field of an electromagnetic wave is given by. So I believe you can do yourself this. So E is given as 3 times sine kz minus omega t along x cap plus 4 times cos kz minus omega t along y cap. So the wave is, so what type of polarization is what asked. So let's, by looking at this, you have a difference of what? Two different amplitudes. Amplitudes are not same. So that means it cannot be, no, it can be linear also, it cannot be circle. Only for circle your amplitude must be same. So linear, let's say you can have linear like this also. The amplitude can go one side smaller, shorter, distant, and another side longer distance. But still it's linear. If you want to be a circle, the radius must be constant. So the moment you see this different, that means circular option is gone. So either it can be elliptical or linear. And the difference is going to be, if it is a linear, then your delta should be, so let's say for linear, the delta must be 0 or pi. For circular, in a special case, your Ex must be equal to Ey and delta must be plus or minus pi by 2. Okay. If anything else, it becomes elliptical. Okay. So in this case, your sine and cos, the difference is pi by 2. And amplitudes are not same. So therefore, it can be only elliptical in nature. Okay. And is it right elliptical or left elliptical? If it is asked. Because you can see here, elliptical, you have two options. One is counterclockwise, another one is clockwise direction. So therefore, how to get this clockwise or anti-clockwise? Then you have to go for the theta. Your theta 1 is equal to tan inverse of the, you have let's say x by sine or y by sine. So basically the tan inverse of cos by sine will be there. So let's try to rewrite this as E equal to B sine, let's put this is phi of D plus 4 times, so this cos can be written as sine phi of t plus pi by 2. Is that correct? Can I add this function? So then what will happen is you have a theta equal to tan inverse of sine pi by 2 phi of t plus pi by 2 whole divided by sine pi of t. And it's going to be cos by sine. Cos by sine will be down. It's 1 by tau. So tan inverse of tan. So probably this, I don't know whether it's a typing error. If it is this is cos and this is sine, then it's a very straightforward. Now it is given as other way around. So now you write this in terms of this, and then basically this is y component by x component, your theta, and then you what you get is this become a cos by sine. So tan inverse of tan inverse, let's say what you get is phi of t. Third terms of phi of t can go like this. No, it's going to be or theta. Someone, what is that? You see? We write amplitudes. So Ex and Ey. So this will be 4 and 3 will be. Let's say 4 and then 3. So 4 by 3 times. So then if you expand this sin pi by 2, sin pi, sin a plus b formula. So okay, we'll do this. Okay, we'll think of this, then we'll get back. See, the point is, if it is this is sine and this is cos, it's straightforward. But because it was given as other way around, I'm just not here. Any suggestion here? To this point? Okay.